Hello, Critica. Which object do you want to choose?
The ball on the bottom left.
Thank you. This is the one chosen.
The ball on the right.
Do you mean this?
No?
Do you mean this?
Yes.
Thank you for your confirmation.
Can I continue? I continue. Okay. So, but my mouse is not working now. Yeah. Can you return my mouse? You click somewhere there already. Okay, can. Then okay, then that's where we actually so-called, then after that throw it in, then after that we actually can actually manage to detect all the gears in terms of that. And this was actually done without any data collection. Basically, we use the synthetic data, etc., and manage to achieve that. Are you clicking? Okay. Okay. Anyway, so after that, we have the question, okay, about sometimes the accuracy is not that good because sometimes people may say the left gear, the left bearing. They may not have enough words like left top, left bottom, etc. Then we started to think, hey, is there other ways to utilize other things to actually do so-called to remove this ambiguity? Then after that, we actually use the gaze because we feel that the gaze is something that's quite natural. Okay, so typically when you want to refer to something, you have a tendency to actually look at it. So we thought of making you this particular feature. Okay, so we actually included it. Yeah, I think you jump one of my slide, but never mind. I can't go back. Huh? Okay, yeah. So basically, we utilize it, okay, by looking at both the gaze as well as the confidence score. Then after that, we actually predict which is the object that the person is actually referring to. So this one is actually a quick demonstration, which actually just not.
Hello, user. Which object do you want to choose?
I want the gear in the middle.
Yeah, in this case, she said the gear at the middle. Okay, so basically the formula is actually up and
Do you mean this?
Yes.
okay on the push over. So
Thank you for your confirmation.
So this is another example.
Hello, user. Which object do you want to choose?
I want the gear with a shaft.
So the gear with the shaft.
Do you mean this?
Yes.
So that's why it's actually say that. Again, all these were
Thank you for your confirmation.
Real data collection all through synthetic data. Then after that, sorry. Yeah, this one is basically just some performance, okay? Some numbers to show that the gaze does actually help us improve lah in terms of ambiguity, okay? Then after that, other than the comprehension part, then after that, we were thinking in the recent years is that, can we push the boundary? Other than just trying to understand what the instruction for the human to the machine, can we also find out more about the human, like the physiological status, etc. Like is the person paying attention, the cognitive load, etc. Is it reaching the maximum, etc. So we thought of maximizing the gaze, okay, rather than just using it for instruction. So that's where one direction that we're actually looking at. But when we started looking at this, we realized that a lot of all this work that's to detect the physiological status, they are actually using good quality gaze data set, which is typically the trackers are usually the Tobii eye trackers, okay, which is of a much higher quality as compared to the HoloLens that I think you have seen, which is just a camera looking at the eye. The HoloLens gaze data is actually much more noisier. So that's where then we started looking into some methods to actually do gaze denoising. Basically, is to remove the noise. Yeah, so for gaze, basically, there's a few things like fixation. So for example, this over here, taking as an example of reading a one particular paragraph, typically we will be able to identify certain events like fixation, whereby he actually look at here, as well as a cut when the actually returning. Okay, so there are some events like fixation, saccades, etc. So the same for looking at images. Okay, so typically we'll a person will look at here followed by here. So these are so-called regions of fixations. Then, of course, I'll skip the technical details over here. Basically, then Kritika actually look into all the various data sets as well as propose a particular denoising algorithm, okay, whereby she actually performed the native segmented linear regression clustering method to actually, this basically is the approach that she did. And this is actually some of the results that is actually in a way illustrated, whereby this is actually the amount of noise that she introduced. And she actually managed to clean up quite a bit of the noise as compared to the existing methods there. So then after cleaning up already, then she actually passed it through the 4-class H&M to actually identify what is basically is the status. What is the event? Sorry, what is the events of the particular portion of the gaze, which include things like fixation, saccade, smooth pursuit, as well as the post-saccade operation. Yeah. Okay. So that is basically we have some methods in terms of denoising. And then, yeah, so this is actually the performance, okay, in terms of the denoising, in terms of the classification of the events. So that's one thing that first that we did first. I think he's controlling my mouse. You're controlling my mouse. Somebody is controlling it. Oh, come on. Okay. Okay. Oh, this is okay. Okay. Oh. I see. Okay. Anyway, so after denoising, the so-called the gaze noise, etc., we thought of trying something to see whether do we have some preliminary results. And this was actually just nice. Because of COVID, we have a lot of online learning. So we have a lot of online lectures, etc. We thought, hey, should we utilize this opportunity to see whether the students pay attention? Okay, so that's where we actually started to do some experiments. Don't worry, IRB is sorted already. Okay, so the students know that we are monitoring, and these are actually not really real students. Okay, in a way, it's not basically it's not part of their accredited modules. It's something extra. Okay, so but anyway, we decided to look at it. Okay, because let's say if this works right, all the laptops actually has a camera. So if we can monitor their gaze, etc., we can actually pick up are they paying attention or they are not paying attention, etc. Okay, so that's where we actually designed this experiment whereby we have a video I'll show you later. Then after that, we have all different types of the distractions like some shopping advertisements, some email notification pop up, etc. to see whether can we actually detect. Okay. Then this one is one example. The left here is basically a simple demonstration of
the vector I mean, in this aspect where there's always a real
that this is how
part
the gaze will look
and
like,
there is an
which is
imaginary
of a
part.
good student. He's looking at the equation. He's
right, the imaginary part actually, the J term actually consists
so
of
one
square root
example of a
minus
good
1,
student,
right?
okay?
This is actually what.
Then, of course, after that, we also have the other side here. Has some distraction with the email. This guy will, you notice that will try to pop and then get a bit distracted looking at all these things. So this is just an illustration of how the gaze normally how we will react. Okay, when we actually have distractions, etc. So we collected a number of all this data, then we perform some form of classification. Okay. Then in terms of the features that we take note, this is actually a list of the features that we actually try to extract before we actually throw it to the network to actually do training to do the classification. The key thing that we identified that is a key is actually the number of fixations. okay, we notice that it's actually quite a strong features because when the person is distracted, I think there's a tendency that he will look here, look there, look here, look there. So the number of fixations actually starts to increase. Okay, so that's a part on that. And then we actually did the so-called we utilized the NLP classifier, and this basically is the results, which actually is about 73% accurate for now. So this is a preliminary work. We hope that we can actually utilize that and see how we can actually go back to the manufacturing sector also. Yeah, to actually to see what are the status that we can actually detect. And yeah, so conclusion. So in these few years, what we have done for our group is that first we have actually performed the domain adaptation, okay, using purely synthetic data, as well as how we can actually use gaze to actually assist in terms of comprehension. So for this part here, all are done using synthetic data. And then after that, we also have performed the denoising of the eye tracking as well as some insights. I'll say there's more insights because I think we definitely need more data to actually prove, to actually estimate the physiological status of the person. So with that, yeah, we also want to acknowledge the funding agency, okay, led by Kenneth, okay, whereby we managed to get this project under the A-STAR AME programmatic funding scheme. Okay, and this is basically the team. Yeah, actually they are the one doing most of the work. Okay, so yeah, some of them are here today. With that, I think I thank you all and welcome any questions. Yes, please. Yeah. How do we get the gaze? Okay, so there's a few things that we can actually do. Okay, like for example, in the outside the demo, we are using HoloLens. So it's an AR goggles. Okay, so in the AR goggles, there's actually two cameras that's actually looking at one on the left eye, one on the right eye. So for HoloLens, there's actually some APIs, etc., for us to extract the gaze. Yeah, so basically how you move, etc. Yeah, we also talked to Microsoft before. Actually, we wanted them to open the pupil dilation. So we hope that they can open up. They were concerned with privacy. So therefore, they don't want to open up the pupil image for us to access. So hopefully next time they will at least give us the diameter. Yeah, at least we can do more things interesting. Dimension of the gaze or the image? Gaze will be 2 degree S and Y. But then again, we have to map it to the image also, because you notice that if let's say I'm looking for this chair, I just say chair. You do not know which chair, so I basically have to map the camera, the image from the camera that's out from the HoloLens as well as the gaze. Then after that, we will actually select according to the pixel. Yeah. Last question. So, did you ask children to join this experiment because the children's gaze is unstable? Yes, that's a very good question. Yes, for our side, mainly we target SUTD students, so it's all above 21. So you are right. And below that, it's definitely an interesting question that it's definitely interesting to explore, because you're right, gaze, children behave differently. Yeah, so that's definitely an interesting topic. Yeah. For that one, I think we need more study protocol, etc., in order to actually investigate on the children. Okay, welcome. Thanks a lot. Any more questions? Yes, please.
How would you use how would you use for example, for inspection in an industrial site? Meaning that imagine that you send a technician that is not kind of new technician, right, to a site, and then he takes some photos and so on, and they say, okay, where is the valve, where is the pipe XYZ, where is this? So see in the image that I see, because it's a very complex environment. For example, imagine at industrial site that has a lot of
Understand. So two comments. Okay, we are not addressing that. Okay, so reason for the one that we are doing here is actually more in terms of the human giving the robot instruction, like this object, that object. So in a way, the human actually knows what to do. Okay, so that's one thing. Second thing is that actually they are in terms of the inspection. it's not done in this word, but there are some companies that actually ask us whether can we actually ask the user, ask the so-called the more experienced inspectors to actually wear the AR goggles. And then we monitor where they look out. Like for example, if I enter this room, I'm doing an inspection of this room, where are the points that I typically look out for it? So that's something that they are interested, so that that information can be passed to the younger generation, because some of these inspections are not documented in the manual. So this is something that requested, but to be upfront with you, we have not done any preliminary work on that. Yeah.
Any other questions?
Okay, thank you.